Now let's talk about the bit operators. Bit operators, right? So bit operators are also very easy, but it's bit tricky, right? Whatever we have seen so far, that is happens at the condition level, right? These are also like a Boolean operations that we are used for the conditions. These are also Boolean outcomes, but this will be applied on top of the conditions. But here, when it comes to bit operator, all these operators, right? All these operator will be operated on top of at the bit level. What is the bit? Bit is basically, let's say this is an integer, so there is an equal representation in the binary that we have seen in the earlier videos, right? Every number or every character or every ASCII character will have the equal representation of the binary, right? So the binary representation will be 0 1 0 1 or 0 1 0 1, right? These are the binary representation. If you are from ECE, right? ECE or CSC, these are a core subject, right? Yeah, in your academic somewhere you must be learned about it. But in case if you are not from the EC or CSC, that kind of branch, for your benefit, I'm just saying, bit is, the binary representation is like, 1 and 0 representation of that particular number. Okay. And so these bit operators will be operated at the bit level. So we will see how it happens. For example, we'll start with the a is equal to 5 and b is equal to 3, the same assignment operator that we are giving, but now this time we'll also keep an eye the binary representation as well, right? For example, for a is equal to 5, right? 5 binary representation is this one. Where can you check? I have shown you one example, right? Binary, integer to binary, into to binary conversion. Let me open binary conversion converter, anything, right? Decimal to binary. Let me take this and decimal to binary. If I give the 5 here, right? If I convert it, right? This is how it is giving 101. If I give the 10, right? It will directly convert and it will tell us like what is this. Okay. So if you want to, there is a separate calculation for that. If you don't want to calculate it, you can use this online examples. Online calculators, right? And so back to our topic. So the 5 binary representation is this one and 3 binary representation is this one. Okay. So what happens when you take this OR operator? This is a bitwise OR. How it works in the sense, it will check whether digit by digit in the binary level. So what is 0 and 0? Oh, sorry, 0 or 0 is a 0. 1 or 0 is 1 because one of the two are true. That's why the outcome is true since this is an OR operator. Similarly, if you compare this third operator, or the right from the second one from the left right hand side, right? If you compare these two bits in the two numbers, 0 and 0 R1 is 1. 1 R1 is also 1. That's why we got triple 1 and 0, right? Again, I'm telling 0 and 0 is 0. 0 or 0 is 0. 1 or 0 is 1. 0 or 1 is 1 and 1 or 1 is 1. So that's why you got this number. So this number is this number is binary representation for 7. Okay. So that's why we got 7 here. When we run this code, it will give us 7. For example, the same thing you can run it with the AND operator. AND operator, what happens? This is again a binary representation. This is again a binary representation. And we will simply see 1 and 1 is 1 because both of them are true in the first place. That's why it is 1. 0 and 1. 0 and 1. One of them is true, right? That's why it's an AND. That's why it is 0. And 1 and 0, one of them is true. That's why it is 0. For AND, both of them should be true, right? And here 0 and 0, both of them are false. That's why it is also false, right? And the final number is 0 0 1, which is in integer. It's a 1. So that's why it is giving the 1. Okay. This is how the AND and OR operator works. All right. And this is the shifting operators. Shifting operators in the sense it's a left shift. The arrow mark is showing towards the left shift, right? Left shift. And how many, what this number will tells? It tells that one digit you should shift towards the left. What is A? A is 5. The binary representation of A is 0 1 0 1. And whenever we are using this particular operator, what does it mean in the sense? I need to shift one bit towards the left hand side. What does it mean? Let me write it and show it here, right? So the binary representation, right, of 5 is 0 1 0 1. Why I'm taking 5? Because we have assigned with 5. Whatever the number you have assigned, you have to take that binary representation. Okay. For simplicity, I have taken 5, 0 and 0 1. Okay. What we are doing, we are moving the bits to the left hand side, right? If it moves to the left hand side, it will melt in the air. Let's forget about this. Okay, this place is empty. Now 1 will be moved to the first place. So the first place will be 1 and 0 will be moved to the second place. So that's why 0 will be here, and this one will be go to the third place, right? So that's why it will be here, and this will be vacant, and the 0 will be appended with 0 here. Okay, so that's why the number is 1010. The equal representation of 1010 in the integer format is 10. You can run this program and we can see that. Okay, and let's run it and see if it gives 10. Yeah, it gives 10. Similarly, right? Similarly, this is a right hand side shift. Right hand shift, what happens again? 0 and 0 1 and 1 0 1. So one bit will be moved to the right hand side. Right hand side. 1 will be moved to the right hand side, right? And which means there is an empty space here. So that's why the 0 will be coming to the first place. And okay, let me also write this one. 0 1 0 1, and there is a right hand side shift operator, and how many bits it wants to shift? One bit, right? So let's move it. 1 will be moved to the right hand side. That means it will be melt in the air. Let's assume. So here the vacant, this 0 will be moved to this place. So the first place in the very first place, 0 will be here, and after that 1 will be moved to here, which means the 1 will be in the second place, and this 0 will be moved to here, 0 will be in the third place, and the empty space, right, this will be prepended with the 0. So this is what the number after applying the shift. So 0010 is nothing but 2 in in integer format. And who will do the conversion? The conversion was automatically taken care by the Python and will give you the output. We don't need to convert to the binary to the, for your calculation, for your debugging, we can, for our understanding, we can converting and I'm showing it, but this conversion and reconversion that was happened internally, which we will not see, right? This is about the bitwise operators. I recommend you to practice with all these bitwise operators anyway to get them more clarity, right? And then now we'll go to the membership operator. Membership operator is also very interesting and very much, very precise in concept, and it's very easy to understand as well. For example, let me take this example directly. Okay, if I give this x in Python, right? This is a string, and this can be a substring x. There is no x in Python. There is no x character in Python, right? So if this is the case, it will give the false, right? Because x is not there in Python. We are asking, is x is there in Python? No, right? So that kind of membership operator we have, like in one membership operator is in, and there is also one membership operator not in. For example, if I give 0, it will say true, right? If I give why? Because 0 is there in the Python, right? Not 0, sorry. My bad. O is there in the Python, right? If I give the n, capital N, can you guess what will give it? What it will give? N is there here, also n is there. It will give false. Why it is giving false? Because the capital N we are checking with whether the capital N is there in the Python or not. There is no capital N. That's why it is given false. Okay. And what else? Similarly, not in, right? The same thing, not in. Not in what in the sense? Capital N is not in Python. If we give like this is true because capital N is not there in this particular string. So that's why it will give true. For example, if I give P, small p, so P is present in Python, but what we are checking, not in condition we are checking. This is not a condition, my bad. Not in operator with the not in operator we are checking. So what it will give? It will give false, right? If I give here, if P is there in Python, yeah, it will give true, right? So this is what membership operator will tell us. And there are also identify operators. Identify operators are also like something like membership operators, but not exactly same. What I mean to say is like as simple as membership operators, right? Here also identify operator. For example, A is 5 and B is also 5. We can check like A is 5. We are checking whether A is 5 or not, right? If A is 5, A is B. A is B. B is equal to 5, right? A is B. It will give the true. If I give A is 10, it will give false, right? It will give false. And it is also give some warning. You can ignore it. Did you mean equal to equal to? What it is saying instead of is, you can use this one. Okay, so probably we will see more about these kind of things in the when we are using the strings. But for now, just for now, I just use this example to explain like this. We cannot direct. It's not recommended to use the values directly. Rather, we can use the variables. Okay, A is B is true, right? If I give B is equal to 10, it will give false because A is not B, because B is 10 and A is 5, something like this. And there is also E is not, right? Reciprocal for is, right? Reverse for is or else, right? 5 is not B, it is correct. It will give true, right? If I give 5 here, it will give false, right? Okay. So far these are the operators: identify operators, membership operators, and bitwise operators, and logical operators, comparison operators, and assignment operators, and arithmetic operators. So I recommend you to download this book and do the practice and read it very well. Okay. And before we end up, there is also one more important concept, right? In operators, there is a concept called precedence. Okay. See, for example, what does it mean in the sense? For example, if you give the equation like this, 2 plus 3, 3 into 4. So what will be the result? Can you guess? The result will be 14. And why it is 14? Because you have given the into here, the into will be executed first. Multiplication will be executed first. After that only outcome from the multiplication will be added to the number that you have given. So that is how it is happening. And if you give like this, right? If you give like this, what happens? Whatever the numbers, what are the operations that you are given inside the parenthesis, it will be executed first. The outcome that is coming from parenthesis will be applied for the multiplication. What does now output for this is 2 plus 3, 5, 5 into 4, 20, right? So similarly, there are set of precedence in the sense whenever we have a very big operation or multiple operators in the same equation, I mean in the same line, there is a Python follows some precedence. Here I have jotted the precedence here, which is the highest precedence and which is the lowest precedence. Precedence is basically the order of executing. Here we have seen, right? If we give like this, the first precedent will be given to these two because the into is given for the multiplication will be given for the highest precedence than the addition. The same thing, if I added the braces here or the parenthesis here, the parenthesis is given for the first precedent, right? That's why it is executed first, and after with the outcome, it will be multiplied with 4. Okay. So similarly, right, here I have jotted it, right? So highest precedence will be given to the parenthesis. After parenthesis, the precedence will be given to the exponential. And after that, this unary ops that we have seen, right, that will be important. I mean, that will come the next. And here the multiplication, division, those operators will come later. And after multiplication, division, floor, and modulus, the precedence is plus and minus. And after this, the bitwise and or comparison, logical, and least precedence will be given to the assignment operators that we have seen above. You can try to recall it again. So if I ask you, right, what is the result here in the sense, if I follow this particular thing, first, is there any brackets inside it? No, there are no parentheses, brackets in the sense parentheses. There is no parenthesis. And what else we have? Exponential. We have exponential, correct? We have exponential here. So this will be executed first. What it will do? 2 exponential 2 which means 2 power 2. It's a 4. 2 square. It's a 4. After that, what we have? First of all, this was executed. 4 is executed. After that, what we have? Into we have, right? Multiplication we have. So 4 into 4, how much? 16. Right? 4 into 4, how much? 16. After that, do we have anything else? We have plus. So 16 plus 3, how much? 17. The answer will be, oh, my bad. What happening here? 2 square 4, 4 into 4, 16, 16 plus 3, 19. My bad. It's not 17, it's 19. Okay. Try to understand this. 2 square is 4, 4 into 4, 16, 16 plus 3, 19. So that's why the 19 is printed here. Again, here also we can try to print it, right? I mean, this is having the multiple conditions, right? 3 is less than 5, which is correct, and 5 is less than 7, which is also correct. That's why it will give true, right? Similarly, you can try to print this one as well. So we can try to guess what will happen in this one. We have a plus operator, we have a bitwise operator. In these two, which will given to the highest precedence, just check here. So bitwise operator is here, but the plus operator is here. So plus is having the highest precedence. That means the plus operator will be executed first. 2 plus 3, how much? 5. 5 left shift, right? Left shift. The arrow is showing towards the left side. Left shift with 1 bit. How much it will give? This is the one, 10, right? We have seen here, right? Somewhere above with the same example. Yeah, the same example. 5 left shift 1 is 10. So that is why here also it's 10. 2 plus 3, 5, left shift 1, 10. So now for you, right? After this video, what I would recommend you is just try to download this file and go through all the sections, code sections and the explanation that what I have given. And once you have done that particular homework, right? I mean, once you read it and once you understand it, just try to do the exercise. Of course, this seems to be very simple and we can doable, but still I recommend you to do the exercise. Then only you will involve and you will get the feel that you have learned something, or else you'll not, by listening it all, we cannot grasp the concept. So just even though these are 4 problems, without executing it, just try to execute in our notebook and just see the answer that what you get in notebook, and here both are matching or not. In case not matching is also fine. Just try to understand why it is not matching. Okay, in that way you can leverage the skills day by day. Okay, practice is very important, as I said earlier, right? Practice is really important to understand the Python or machine learning or anything. Okay, that's all for this video. Bye.